box to communicate with the organizers. But also, if you have any questions, please write them down in the Q&A box or in the chat so we can address them shortly after the presentation. We also will have a discussion session at the end. So please, if you would like to speak, raise your hand and we'll unmute your microphone. So you can ask a question in the Q&A box, or you can also raise your hand and we will unmute you. Eventually, we'll have a mix of both during the Q&A session. So just to kick off quite shortly, I will go over the program and then I will give the word to the opening session. So we'll have a short opening session with remarks from our director and a regional representative for the UNESCO Regional Office for Southern Africa here in UNESCO, followed by Director of the IHE Delft Institute for Water Education, Professor Eddie Morse. Continuing after the opening session, we have an overall presentation looking at the Open Water Network, looking at better water resources management tools, and about sharing knowledge on water. This will be presented by Dr. Anne van Greensven, who is both working at IHE as well as, working as an IHP focal point for Belgium. After that, we'll have an overview of the online course given by Dr. Hans van der Kwast, who is the IHE Senior Lecturer in Geographic Information Systems and Spatial Data Management. After which we will go into an open discussion and Q&A session where you can have any issues you want to discuss. After which we'll announce the launch of the online course, and we will finalize with some closing remarks by the head of section of the Hydrological Systems and Water Scarcity section in headquarters, Dr. Anil Mishra. So with that program, I would like to kick off, and I would like to give the floor to our Director and Representative for UNESCO of the Regional Office for Southern Africa, Professor Hubert Keijzen. Hubert, please, the floor is yours.
Thank you, Koen. First of all, can you confirm that you hear me?
We can hear you, we can see you. Please go ahead.
Great, good. Yeah, thanks, Koen. And I would say, dear water sector colleagues and friends, greetings from the UNESCO Regional Office for Southern Africa. We are based here in Zimbabwe, in Harare, the capital, and cover the SADC region, the Southern Africa region. A very good afternoon and welcome to all connected to this launch webinar of the online course on programming for geospatial hydrological applications. And I'm really happy to see so many of you connected. I just looked, there's over 200 participants connected to this launch webinar. So that already indicates quite a broad interest in this course. And I'm also happy that we are teaming up with our friends from IHE Delft. Good to see that Eddie Morse, the rector of IHE, is on board. Good afternoon, Eddie. Good afternoon, colleagues from IHE. Very happy to see this joint venture happening. Dear colleagues, we all know the slogan, water is life. And we know that without it, our life expectancy shrinks really to merely a few days. So indeed, water is life. But I would say, judging from the way we manage water, it seems that water continues to be one of the most undervalued and probably most poorly managed resources on planet Earth. Climate change and also changes in land use and land cover patterns have triggered drastic changes in the dynamics of the hydrological cycle. And as a result, water managers face considerable difficulties and also uncertainty in determining water availability. To ensure water security and improve sustainable water management, we need to fill gaps in our understanding of the spatial and temporal distribution, but also the movement, the dynamics of key elements of the hydrological cycle. And that the components are, of course, like precipitation, surface runoff, groundwater, soil moisture, and evapotranspiration. The development of geospatial technologies such as GIS and remote sensing provide really robust tools to monitor, to model, to analyze, and also visualize both regional and global hydrological cycles. With extensive spatial coverage and high spatial and temporal resolution. So the technology has really developed in that sense. This webinar is a first introductory step where we try to fill this gap. We fill that gap through the exposure of participants to the basic essential skills that researchers need in dealing with spatial data. The course was developed, as Koen said, in a collaboration with IHE Delft Institute for Water Education. And it is part of a UNESCO project. You saw the slide that is still currently on. The slide that gives the project title, Enhancing Climate Services for Improved Water Management. And this project, it seeks to build capacity for national and regional stakeholders to transfer the knowledge and technology for climate services. This project has contributed to the promotion and the improvement of general climate literacy in line with the recommendations of the special report of the Intergovernmental Panel on Climate Change. And it has done so in the ocean and chrysosphere in the context of a changing climate. By strengthening the provision of reliable climate services and therefore increasing resilience to climate change, this project has also contributed to the realization of the global agreements, such as the Agenda 2030 and its 17 SDGs, the Paris Agreement, but also the Sendai framework on disaster risk reduction. And in doing so, the project reinforced the role of water, the position of water as the ultimate connector among the global commitments towards a sustainable future. Dear participants, this course is evidence of UNESCO's commitment to building a scientific knowledge base and to support its member states to sustainably manage their water resources. And this is done not merely via, for instance, my office here, the regional office, or all the other offices in the region. This is done through UNESCO's wider water family, which comprises of the global intergovernmental hydrological program, as you know, the IHP, but also the World Water Assessment Program, and also look at the large number of specialized water centers. We call them Category 2 centers that have been established under the auspices of UNESCO. And this includes the IHE Delft Institute for Water Education. But in addition to that, 55 UNESCO water-related professorial chairs as well, and linked to that, to the professorial chairs, we also have the university twinning programs, and there are some very strong uni-twin networks, as we call them, in the field of water. Today, and as part of such UNESCO Water Family initiatives, we are happy to be able to offer this course to you in close partnership with the IHE Institute for Water Education in Delft. In doing so, we built really on a long-standing collaboration between UNESCO and the IHE Delft, which date back a long time when I was still in the Institute in 2003. And at that time, the Institute joined the UNESCO Water Family as a so-called Category 1 institute. That means IHE Delft became part of UNESCO. This has meanwhile changed to a Category 2 status, but we consider IHE as a very important capacity building and research partner in the water family. Dear participants, UNESCO stands ready to support its members, which often are also transboundary in nature. And this course will make use of open software that is publicly available under an open license that grants others the right of access. You can access it freely, you can adopt it, you can adapt it, you can share it, you can study it. So the software is basically yours. In addition, the course itself, so the offering of the course, is also free to attend. And universities can adopt this course as a module, attach credit points to it, whatever they want to do. It is free for access by all. And the learning materials are freely accessible on the UNESCO online learning platform. And this is, of course, in line with our policy, the UNESCO policy on open educational resources and also on open science. This course will equip participants with the necessary skills to develop geospatial techniques, improve their understanding of the hydrological cycle, and to solve scientific and practical hydrological challenges for sustainable water management. I really look forward to the further expansion of this fruitful cooperation with IHE Delft. And I wish a most successful and productive webinar and also a very successful online training course. Thank you very much, and back to you, Koen.
Thank you very much, Hubert, for those welcome remarks and also for making the link with IHE, which is, of course, a very strong link. And I'm now very happy, honored, and also it's a pleasure to invite Professor Rector Eddie Morse to give us also a bit of an introductory remarks from his side. Thank you very much, and please, Eddie, the floor is yours.
Okay, thank you, Koen. Just to make sure that you can hear me, thumbs up from
yes, we can hear you, we can see you. Please go ahead.
Excellent. Huub, thanks also very much for this, I think, a very nice introduction. I also very much appreciate that you mentioned the collaboration. I think IHE Delft is proud to be a member of the UN Water Family and also of the UNESCO Water Family, which I think is a very important society to be a member of. And I think within this collaboration, we are also quite happy to support I think an endeavor as this one. And I think you already mentioned a bit the problems that we are facing, but also that those problems will accelerate with the increasing population density, but also with climate change, as was mentioned before. What I would also like to stress is actually, and I was very much touched by that, that was in July last year, the Secretary General announced in July that if we ever want to achieve the Sustainable Development Goals in 2030, we need to do something. And we need to do that, especially in SDG 6, which is the water related SDG. And he was saying this because for him, it was clear that if we don't move forward within the water SDG, we will also not be able to achieve all the other SDGs that strongly depend on water. And that's not only water availability, it's also about water quality, it's about sanitation, it's about water governance, it's about everything that touches with water. And I think for me, that was an appeal that was clear. I think this course is very nice because as far as I'm concerned, we're combining 3 accelerators that were mentioned by the Secretary General in one go. So the first one was the capacity development. And of course, that's what you do when you do a training like this. The second one is innovation. I do think that what you will hear also during the course is indeed about innovation. That's why we also think that capacity development is such an important accelerator, because you need new knowledge, insights, if you ever want to make this acceleration to achieve the goals. And the last one is improved data and information. And of course, talking about GIS and about data, that's what I think is required. This later one is sometimes, I think, a little bit overlooked because people want to or other infrastructure. But if you want to be and make informed decisions, you need this information and you need the data to make the right decisions. And that's, I think, where this course is also very important for. So I do hope that in this combination of GIS and Python, where you also will learn to make a step that enables you to really use this in your specific case, I hope you will fully enjoy that and also will use that. In the case that you're really caught up by this, then please feel free to contact IHE if you want to follow it up by another course, or if you want to collaborate on the research side. I think that's also quite important. And I do think that it would be quite nice to do that under the umbrella of UNESCO. So I hope that it will not remain with this course and this webinar, but that we will be in touch later on. And I'm looking forward to your input and efforts, and I hope that together we will manage to achieve the Sustainable Development Goals of 2030. With that, thanks very much for giving me the opportunity to say a few words, and I wish you a very, very good course and webinar. Thanks, Koen.
Thank you very much, Eddie, for those words. And of course, indeed, this is a starting point as well. We see it as such, and hopefully this could also lead to further work in the same area. And I think the next presentation will be given by Dr. Anne van Griensven is actually giving us a bit of a broader scope of how these tools and how this work fits into the open water network. So please, Anne, if you could give us a bit of an overview of that broader scope. Thank you very much. Thank you very much, Eddie.
Thank you very much, Koen. Okay, I will now first start to upload my presentation. You should see it now. I hope it's there. Okay, thank you. So I will talk about the open water network, and I will try to convince all of you that it is important to have a better water resources management by sharing knowledge on water. So the background of this talk is open science, which is becoming more and more important and stressed. And this is a definition of the EU that say that it's an approach to the scientific process that focuses on spreading knowledge as soon as it is available using digital and collaborative technologies. And we are somehow implementing this open science within the water domain through the open water network. And the main goal of the open water network is to share knowledge on open source software and open access tools, all within the domain of water, so to support water resources engineering and management. So we started with this in 2011 with an open water symposium that was organized at IHE Delft, where we had both presentations as well as workshops of open source tools. And this was a big success, so we decided to continue. So it has been organized more or less every 2 years as a kind of a physical meeting, offering a platform for presentations to share new results, as well as to provide training through workshops in computer rooms, typically organized. So we did this further in Brussels, Addis Ababa. This was also supported by UNESCO, another one in Brussels, Arusha, and then the last one we had before COVID somehow disrupted physical meetings, was organized in Rabat, funded through UNESCO. So that's how we started, but that's not where we are now, of course. We are more moving towards online activities. So we are building at this moment an open water network platform where we also provide access to open source software and data and knowledge. So here you can see it's a work on the process, but we are providing access to e-learning data. We are building a platform for Internet of Things. We provide access to software through a GitHub repository. So this is somehow an access point to a lot of information and knowledge on open source software and data for water applications. I think important in this is the e-learning material. This is something we are getting more and more involved. It already started before COVID, but it's of course also accelerated through the COVID situations we are in now. So we are now moving more from providing access to data and software also to providing access to open education for water resources engineering and management. At this moment, we are still in initial steps to build a Moodle open water network platform where we aim at providing course materials that can be used by different programs across the world that want to provide courses on hydrology or water resources management or other topics that are typically given in water education. So this is something we are recently starting, and of course, like today, we are also getting more and more involved in webinars. We're also offering webinars. I will just mention the one we are currently also offering. It's a webinar on water management using Internet of Things technologies, remote sensing and citizen science. So you can see it's running right at the moment. All these courses are also offered through our YouTube channel. And also important is the support we got for these webinars from UNESCO IHP, but also the strong collaboration with the EMWRE project, which I will just explain briefly. It's a project where we develop an e-master on water resources engineering, and this is done together with UNESCO IHE and VUB, the Free University of Brussels, who's coordinating this project, but of course with partners in Palestine territories and Jordan, because the overall goal is to run this master in the Middle East, in Palestine and Jordan. So this is also a very important project that helps us to push further the e-learning activities that we are doing at the moment. So this is, I think, a bit the background of the Open Water Network, but also where we are going further. So summarizing, we focus on, let's say, 3 components: open data, where the main activity now is going towards the Internet of Things platform, but we also offer workshops on data management. GIS, of course, is also very important in this context. We provide access to free open source software, where the GitHub repository is the main platform for this, and open education. So here we are offering several webinars, online trainings. We also have a very popular YouTube channel with thousands of views of certain videos that we posted there. And we are at this moment also building this Moodle platform to support water education masters worldwide. So the key is the sharing. That's the main thing we are doing. We share data, tools, information, knowledge. And with this, we want to support citizen science, for instance, with the Internet of Things platform, but also to support community model developments, like we see, for instance, in the soil and water assessment tool. But we also more and more want to provide open education on water topics. But the final goal is to, at the end, support and promote knowledge-based and transparent decision-making. And we see in the COVID situation that this is becoming more and more important to use science and experts in the decision-making. We also realize more and more that this will become very important within the climate change context. Definitely, this is an end goal which is just very important. So that's my main message of today. And thank you all. And you're all, of course, welcome to join the Open Water Network or to view one of our videos or the materials that we provide through our Open Water Network platform. Thank you.
Thank you very much, Anne, for that overview of the Open Water Network and all the tools and methodologies that will be accessible through the platform. And of course, the linkages with both IHP and IHE as well. So thanks for that. And I think we can then move towards the topic of the day, which is to give a bit of an overview of the online course on programming for geospatial hydrological applications. And that will be provided by the main author of the course, Dr. Hans van der Kwast. As I mentioned, he is the IHE Senior Lecturer on Geographic Information Systems and Spatial Data Management. So please, Hans, the floor is yours.
Hello, hope you can see the screen.
We can see you and we can hear you. So the floor is yours.
Great, thank you. Thank you for the nice introduction presentations, which clearly shows the importance of sharing knowledge and sharing data, open education. And this course specifically is a course that I've been thinking about a long time, and there were bits and pieces that were ready. But I never had a chance to really put it all together in one course that really addresses the basic user who wants to kick off with programming and to maybe in a later stage develop him or herself further in using programming languages for geospatial hydrological applications. So I'm very happy to, in this Open Education Week and collaboration with the UNESCO Water Institutes and others to make this possible. Just a short introduction about myself as being the lecturer of this course. I'm a physical geographer by background. I studied at Utrecht University in the Netherlands. I did my PhD at the same university, together also with ITC, University of Twente nowadays, which was about linking satellite information with soil moisture modeling. And there I already started to learn a lot of Python. We didn't in those days have classes in that, so I had to learn things myself, but always was supported by other people and sharing knowledge, which also happened when I started working at VITO in Belgium, the Flemish Institute for Technological Research. A great time where we had a good team of people working on Python, and we had regular meetings to share knowledge. We had a wiki page. And then in 2012, I started at IHE Delft. And there I had some short courses, which I still have on programming, which has some elements of this course, but this course, of course, a bit more extended. And I've also been working a lot on advocacy for open data and open source software. I'm a board member of the Dutch QGIS user group and QGIS for hydrological applications, which gives a good basics on how to use QGIS for analysis of catchments and data on hydrology. My main interests are open source GIS and modeling. I'm also a QGIS certified instructor at IHE. We also offer the certified courses. Integration of remote sensing for hydrology. I work since the beginning of this year with the water accounting and water productivity team, which do very interesting things with linking GIS remote sensing to hydrology. I've been doing also workshops for the Open Water Network that Anne already mentioned, related to spatial data infrastructures, the sharing of data, and so one of my important things in capacity development projects that I do for IHE. And of course, field work and field data collection is also a nice thing. If you want to be in touch with me, I'm on social media, and you can contact me by email. And if you're enrolled to the course and you have questions about the course, then Koen will tell later where you can post your questions about the course. So let's talk a bit about this course. The learning objectives of this course are that you will be able, at the end, to manage files and folders using the command line interface, to use GDAL from the command line to convert GIS formats and reproject GIS files, to use the command line for batch processing, to make scripts in Python, to use the PCRaster Python library for map algebra and raster analysis, to use also PCRaster for dynamic modeling, to create your own spatial temporal models in Python, and finally to use PyQGIS inside of the QGIS desktop and outside of it. And in this presentation, I'll give you a little tour along these different objectives and the modules. But first, I think you are in the right course because it is an essential skill. It was already mentioned in one of the previous presentations in this webinar, because it will really save you time in the future. If you need to process the big amounts of data that are available now on the internet, the big data movement, artificial intelligence, then doing that all through a user interface by clicking would not bring you much forward, and it will cost a lot of time. And scripting languages allow that you can automate processes, do batch processing, do more advanced type of analysis, and even do spatial dynamic modeling. We will be looking at the so-called high-level scripting languages that are closer to the way of thinking of scientists. So we don't have to bother about bits and bytes and where the memory is managed in the computer, but we write code that is very similar to the way of how scientists write their expressions, I would say. Example level scripting and programming languages are DOS batch files or Linux shell scripts. Many of the engineers use MATLAB. We will use here Python, which is free and can do the same and more compared to MATLAB. There are some other languages, and we will cover PC raster. Ours is very popular for modeling, and also has a very good statistical analysis toolkit that you can use also for spatial analysis. But we have no time in this course to cover that. So why should I learn scripting? So automation, as said, can save you a lot of time, but scripts also keep things consistent and make it portable. You can share the script with another person, and things become reproducible, and people can reuse and build on it if it's readable and if you have good practice in writing your scripts. And it looks a bit scary from the first time if you look at such a black screen with a lot of code, but it's not as difficult as you think. And if you are not learning these skills at this moment, someone else will, and I will show you some statistics on that. Some examples. There was some years ago a student, and she was converting 800 MODIS HDF images. That's a kind of data type for a satellite image. And she wanted to convert it to GeoTIFF. It's not this example that's here on the screen, but it's related. And after 300, she came to me. She was doing 300 by hand in QGIS, which works, but it just takes a lot of time. And this code here on the screen shows that you can solve it just in a couple of lines of code. It's not exactly the same example, but this one converts all the TIFF files to a new projection, and it clips it through a polygon to give, and it's put in a batch file, and in this way you can, in a few lines of code, process the whole folder, and take a cup of coffee and come back, and it's done. But I found that that was an essential skill missing in the curriculum, and I still see that at universities it is not mainstream to have these kind of courses in the curriculum that can save later a lot of time, but as I will show later, it will also have a high value on the labor market. Here's another example where we have a model output for 30 years of a land use change model. And with this script of 15 lines, we can convert the format that comes out of the model, is the Idrisi format, to the PC raster time series format to be further used. And it's just 15 lines of code that runs in a few minutes, all the files in the folder. And if you have to do that by clicking, it would probably take at least an hour. And for larger data sets, it can take you days to do that by hand. That was a Python script. And why learn Python? Well, when I worked at Vito, we had this slogan that Python is the duct tape of the programming languages. You can use it for multiple functions. It's not specialized in something specific. It's you, the user, the programmer, who decides how to use it. And it's open source. So you can contribute to Python itself, but you can also, without a license, share your code and people can run the code. Also, if you work somewhere else, you can share the code with your colleagues, and they simply have to have some knowledge about running Python code. And it runs on any platform, Windows, Linux, Mac. And as I said, it's multi-purpose, so you need to determine what you're going to use it for. In this course, we'll focus, of course, on geospatial hydrological applications, but you can use it for data mining, a lot of things that are mentioned here, CFD modeling, and all kinds of different data processing that you can do with big data. As promised, I show you here that there's a big demand in the labor market to have these skills. This was a search I did yesterday for this presentation, and you can see that almost 400,000 Python jobs are posted for worldwide jobs on LinkedIn. So with this skill, you become valuable for the labor market. But also if you stay in academia or become a researcher, it is essential. But as you see here, it's also in the industries. The course consists of 5 modules that cover these different learning objectives. The first module is an introduction to the command line interface and GDAL. Then you'll get an introduction to Python with all the concepts of Python. It's an object-based programming language, so you're introduced to these concepts. Then we are going to use Python libraries for map algebra, followed by a module on dynamic modeling with the PC Raster Python framework, and then the PyQGIS language that is used in QGIS, but also outside of QGIS you can use it. Let's start with what is offered in the first module, the command line interface. And yeah, that's when I start feeling really old. By coincidence, today is also my birthday, but with this slide I feel really old. And when we started communicating and also reviewing the course, a lot of nostalgia came up with other people organizing this course, because people of my age grew up with computers that didn't have a graphical user interface, and you use the command line, the DOS box. Here you see an example on the upper right, to communicate with the computer and to execute commands and to run programs. And I realized that somewhere early 2000s, when I started working as a lecturer at Utrecht University, that the first generation students arrived that have never worked with DOS. And the first question that made me realize it was, lecturer, I have a problem. I can't delete this. I can't remove this C period / strange thing. And I said, yeah, that's the prompt, and you need to type your commands after that. So a lot of nostalgia. When I grew up, we started running code for games, and these programs still run on your mobile phone, for example. But this example of Snake was also my first exposure to programming for GIS. When I was at Utrecht University, we had to make the Snake game in our spatial programming course. In those days, Python didn't exist yet, so we used other languages. But nowadays, you could program that also in Python. It's a spatial problem. You need to keep track of where the snake is. And there are all kinds of rules. It shouldn't hit itself or the walls. So it's a dynamic geographical problem that you need to solve. But okay, all this nostalgia, all great fun for the old folks here. But what do I in the 21st century need to do with DOS, with the command line? Well, it is very important and still very relevant, because you will need that knowledge of your navigating through your file system with command line commands. In the course, you will learn about absolute and relative paths. You will learn how to change the directories, how to copy files, and all these things. And this is often missing in these kind of courses, and I find it very valuable that, that you learn this, and we don't assume that you already know these things. It's also important that you know what is behind user interfaces that you use. When you drag and drop files in your Windows Explorer, all these commands are still executed in the back end. And also those batch files that we use to automate things, they are still used. I did a search on my modern laptop, and I had 120 batch files on my computer. So it might look old and dusty in those black DOS boxes and with all this code, but it is still very relevant, and I would say an essential skill to have if you go into programming for geospatial applications. After introducing you to the command line interface, we go into using the command line interface to perform GDAL commands, which is one of the most important tools used in GIS. I always say to my students, if I'm dropped on Mars and I don't have QGIS with me or any other GIS software, but I have GDAL, I can still do a decent amount of my work, because most of the buttons you push in GIS or that Google uses, or it's probably on many tools that you use and run even on your mobile phone, GDAL is a component in that. It translates raster and vector data and projections, and it's also an essential skill that you need to learn. Here you see how it's used in QGIS. If you reproject a file, you fill in the dialog, and you see that it builds up this command. And now in the course, you will learn how to build up these commands yourself. And if you want to automate things, then this is much easier to loop over if it's a scripting language than to every time fill in the dialog and run. Therefore, if I had face-to-face classes with all of you, I would normally give you this button. It's a bit of a word joke. I don't like buttons. I love coding. I hope you get enthusiastic about it also in this online open course. And then GDAL can be used in the QGIS interface. It can be used at the DOS command line or the command line interface of Windows or Linux or whatever, but you can also use it as a library in Python. So you'll also learn how to import libraries. That's the real power of Python, where you can integrate it with other Python code for pre-processing your data and then visualizing or do modeling. But what's this Python? What has it to do with Snake? It has nothing to do with the Snake game, but it was developed in the early 90s by a Dutch developer, Guido van Rossum, for the Mathematics Institute in Amsterdam. And he worked for Google and Dropbox too, but he's now retired, and Python is now maintained by the Python Software Foundation. It's open source and it's further developed and improved further. And it is not named after Snake, but after Monty Python. I felt a bit in my first classes that it has the same effect of explaining the DOS boxes to young students, but this is also something that you, something culturally that you need to experience. So if you don't know, if Monty Python doesn't ring any bell to you, just after this webinar, go to YouTube and search for Ministry of Silly Walks. And then that's the kind of humor that the developer of Python appreciated and therefore called the programming language Python. And it's really funny. And in a face-to-face class, I would always show Ministry of Silly Walks. So what's specific about Python and why did we choose for that language? Again, it's general purpose, so it's not specifically for statistics or for GIS. Those skills can be used for any thing that you need scripting and programming for. It's high level, so it's very readable. At first you would say, well, he said it was very readable, but when you get used to it throughout the course, you will be able to see that it's more human readable. It's really a language that focuses on the readability. It uses the indentation instead of all kinds of strange brackets and ugly looking things. And it supports different programming paradigms, object-oriented, as I already said. It's imperative, you don't need to compile it, and it has a very functional and procedural style. You will learn more about that in the course. Dynamic type system, you don't have to declare everything specifically before. It will know what you mean, but you can, of course, override the typing of the data. It will take care of the things that you as a researcher don't want to take care of, the automatic memory management, for example. And already the standard Python has a comprehensive set of functions that you can use. But that's not the real power. The real power is in the libraries. It's not like this beautiful library of the Rijksmuseum in Amsterdam, but it's a digital library of code. And there are really a lot of libraries, and we can only cover very few of them to give you a gist of what libraries are. But they add extra functionality from third party to Python, and NumPy is an important one that uses MATLAB-style arrays to do calculations in Python. You can convert GIS maps to NumPy array format and do all kinds of matrix calculations with it. If you bring that to another level, you'll probably need pandas for data processing. A very advanced library, and matplotlib for plotting. We'll briefly cover this in the course, but our main accent on libraries goes to map algebra with PC raster. And for the course, I translated my QGIS course on map algebra to Python. So you're going to do exactly the same exercise as in the book and in the online courses, QGIS for hydrological applications, and solve this problem of finding wells that are accessible in a study area following this workflow, but then in Python code. And the great thing is, in the end, you have a piece of code that you can play with and run it again for different scenarios. If you want to change these conditions, you just change the values in the script and run it again. While in a graphical user interface, you need to do a lot of clicking and repeating the whole process. The second thing that you will learn is to interpolate groundwater levels using scripting. We will have borehole data, groundwater level data from an open data set that we will interpolate with different methods, and we'll discuss the different results. Here you see IDW interpolation and Thiessen polygons, very colorful here. The third component in that map algebra part is the stream and catchment delineation, very important in our work, where we also repeat the whole procedure that is in the QGIS for hydrological applications book and courses. But then without clicking, we start with the same 4 GeoTIFF SRTM tiles, open data, and we end up with the rivers in the Ruhr catchment and catchment boundary and the flow direction using these PC raster operators. And the great thing is that you can use the same in modeling. That will be the next step, to develop a rainfall runoff model. We will use as an example the stream model that has been applied in different places, but we will look at the Mara River Basin. And then you can, in the end, have this discharge result in space and in time, and for every pixel you can get a discharge. Then we will dive into PyQGIS, where you're going to make this tool, the stage volume tool, by using PyQGIS in the QGIS interface. And the stage volume is basically a bit like a rating curve, but then for lakes or pits, where you know which volume is in the pit corresponding with a certain elevation level that you measure. And by using the script, you will get this result, the stage volume table, and it gives us for different levels of the pit, different elevations, how much volume is there. And you see here that if you use the data plotly dialog, you can make easily this graph. So this is the stage volume curve, where you only need to measure the water level in a lake, for example, and read then the volume. Then we're going to repeat that, but then in PyQGIS outside of QGIS, and we end up also with the graph, but then in Python, completely Python without touching the interface. The examples that you've seen here use Jupyter notebooks. That is a technology that we use for these courses. Part will be in walkthrough step-by-step manuals on the Open edX e-learning platform. But part of it will also be Jupyter notebooks, of which a certain part, the beginning, you will run them completely online, but later you learn how to run them locally on your computer. Jupyter stands for Julia, Python, and R. And it's very interactive. You see immediately your results, and we can also plot maps and graphs there. And it comes with Anaconda that you're going to install on your computer. And those materials are on GitHub, which you can also further develop and use in your own courses if you want. And we access that through also very nice technology, through a binder that can run Jupyter notebooks from your GitHub. And Google also has a similar tool, Colabs, Collaboratory, where you can also run this from the repository. That was my presentation, which gave you a tour along the course. I hope it makes you enthusiastically to join and to follow this course. And I hope it also shows the importance of these essential skills for your future career, whether it's in private sector or in academia. I think it's very important. I give the floor back to Koen.
Right, thank you very much, Hans. And actually, just before I continue, first I would like to wish you a happy birthday. And I think this must be your largest and most global birthday party so far, with more than 300 participants. So I think thank you for making time during this precious day, and of course, wish you good health and a good birthday later on. So I think we're now. Thank you. So now we're actually at the point where we want to hear from you. If I just get the agenda up there. We have some open discussion, and we have some early questions, but we also have some hands up. So maybe we can give first to colleagues the floor. So if you want to raise a question, please raise your hand. Sometimes you do that by accident. So make sure that if you raise your hand, you do it on purpose to ask a question, so that we can indeed hear from you which you would like to raise. I see 3 hands up. I will start with those, and at the same time, we'll manage some of the questions from the Q&A box. So I will give the floor to Kinilwi Mushi. So if you're able to speak, please unmute your mic, and then you can ask a question. Go ahead.
Hi, Dr. Webers. I have 2 questions that hopefully can be answered within the given time. The first one is I work for the biosphere in South Africa, and with me attending this course will mean transcending the information to my fellow colleagues and other people I work with. So what's the prerequisite information, or what's the prerequisite knowledge that my fellow colleagues need to have for this course? The second one is, how much time will I need for this course if I myself have to take the course? Thank you.
Thank you for your question. On the first one, the prerequisites, I think you need for these kind of courses a decent knowledge of computers. So if you're already struggling with finding your way on your computer, then this might not be the course for you, because we really need to go into to the command line and finding things on the disk, and also you need to have interest in it. But besides that, it's a beginner's course. So if you are aware of how you use your computer, then it should be feasible with logical thinking to get through this course. There are no other prerequisites. Your second question, can you repeat that again?
Sorry, I was muted. My second question was, how much time will I need, like weekly, because I'm doing this off work?
Yeah. So we can only estimate it. It depends a bit on your own speed, how fast you grasp the knowledge. But I estimate it at around 40 hours, and we spread it out over 2 months in the course. So that would be at a normal average pace, I think, that you can expect that kind of effort.
All right, thank you. We have another person who would like to speak, Oreditse Kesalopa. You can unmute if you want. We give it one more try. Oreditse, if you want to speak, this is your option to do so. If not, we'll give it to the following person. Okay, so I have Mohammed as well. Please, Mohammed, if you want, you can unmute yourself.
Hello, everybody. I'm Mohammed. I'm a PhD candidate and a researcher at Fuzailul University at Water Resource Management Research and Application Center. I have some limited experience in spatial scripting. I would like to ask the instructor about the way of automation processing in QGIS. In general, I have this problem with this paths to define the list of TIFF files, or even the list of vectors. So since you already mentioned the absolute and relative path, if during the course we'll have some examples how we can recall the GIS material, let's say TIFF files, thousands of TIFF files, to do the same process within QGIS, because I think in the other ISRI products, it's taking the absolute path directly, but in QGIS, I have a lot of difficulties in this course. So if you can just enlighten me in this point, I would be grateful. Thank you.
I think that would be mostly covered, and if you still have questions about it, then you can use the discussion forum there. But as far as I know, it should not be too difficult with the steps offered to load your files from disk in QGIS, with PyQGIS, of course.
Okay, we also have Pius Onoja to speak, so I'll unmute you if you want. Pius, if you want to speak, go ahead.
Hello.
Yes, we can hear you. Go ahead.
Well, my question will be, when will the program commence? And what is the financial obligation?
Right, I think we will have that just after the discussion. I will show you how to get to the course and we'll share the link. But also it's not a paid course, it's an open course, meaning that anybody who wants can join the course. So there is no cost attached to joining that course, and it will be open for 2 months. And it actually starts in about 2 minutes from now. So after this session, you can actually start learning.
Okay, that's good. Thank you.
Hello, can you hear me? Well, I think you hear me now. Do you hear me now?
Yes.
Yes.
Okay, thank you. Well, thank you first to the IHE, to UNESCO, to the Clean Water Operation for letting us to study this course as an open course. Thank you to Hans and giving him a congratulations for his happy birthday. I would like to make a question more about how we can explode the skills that we are gonna learn in this course. And my specific question could be how to convey all the insights from the data processing to decision makers. Graph maps can be a good option, or is it better to prepare documents and even, for example, Jupyter notebooks to transfer or to convey those insights to decision makers? Thank you.
That's a very relevant question. Here in this course, we target people who do the work to process data and to etc. That's not necessarily at the stage already to communicate results to the policymaker, which it would be a study on itself. I have some teaching materials on that where I always explain that you need to really well know who your end users are. And normally this stuff that you learn in this course is more at the scientific side, where you go into prototyping and check your theories and making your model. If it needs to be in a production environment, you would probably need to work together with a software engineer to make a decision support system, or to put it on a website in a web development interface. So these are all choices you need to make for the end product, and we are at the beginning of that whole process in this course. But there's a whole trajectory. How do you bring it to the client, and what do you communicate? And it's also very cultural. Are users used to looking at maps and graphs, or does it need to be more narrative, or do you need to make videos of it? So that's a whole world of things that you can explore, and Python can be part of that. But you also need probably other skills for that.
Okay, thank you for that. And we have also Cherner Jallo. If you want, you can also take the floor. Cherner, if you want, you can speak. Go ahead.
Yes, hello, my name is Cherner. I'm from Sierra Leone. I joined late because of internet constraints, but I want to know if the material that we are presented will be available. Also, some of my colleagues at the office want to be part, but we are not registered. Is there a way that they could be part of the program? Thank you.
Right, maybe on offline learning, it might be interesting. We could share maybe some of the documents, but I think for purposes of accessing the material, you would need to be able to at least register once and get access to the course. The course is free, and as I will indicate in the next presentation, you can see how you can register, and it's still open. We currently have over 850 people registered to the course, so there's no limit to that. So if anybody else wants to join, they're free to do so. Maybe Hans, if you want to come in terms of offline information, if people can access it offline in some way.
Yes, most of the materials can also be accessed offline. If you have any problems with the materials in the beginning, to make it easier for you, are offered online, but with the things you learn a bit later, you could also download them and use them offline. But then you will not have that knowledge yet. So if you struggle with that, just post it in the discussion at the e-learning platform. So I can guide you to where you can find how to use it locally already. But you might need to jump a few steps in your learning curve to do that.
All right, I see two more hands up. I have Karimullah Sifat. I will give you access to speak. Please go ahead to mute yourself. We have some challenges hearing you.
Can you hear me?
Yeah, a little bit cut up. Maybe if you can speak very slowly.
Thank you for. Yeah, thank you so much for providing such a helpful webinar. My question is that will this scripting, Python scripting, which will be covered in this course, be thank you. My question is that will the Python scripting, which is covered in this course, will be applicable with the ArcGIS? I mean, can we use the scripting along with the ArcMap? Thank you.
You will learn general knowledge of Python scripting, which is applicable to any software that uses Python. But for specific ArcPy functionality, you need to learn that, and you need to have a license to run that. We will not cover that in the course.
Right, so indeed it can be generally useful, but of course we're not specifically focusing on proprietary software here, since ArcGIS of course needs a license. But of course, if you know Python, you can use it in any other application you would like, such as also ArcGIS. I have one more speaker asking for the floor. That's Sponizo Njaja. Please go ahead. Njaja, please go ahead.
Oh, hi, Dr. Kuhn and colleagues. My question is more with regard to QGIS. I see that the program is focused more on QGIS and programming in Q. So I just wanted to know if there are any, causes, because I'm not someone who has been working with Q mostly. I have been more exposed to ArcGIS rather than Q. So I just wanted to know if there are any causes that Prof can recommend with regards to learning more about QGIS, which are open source or otherwise. Thank you.
Yes, thank you for your question. Last Friday, I had a webinar as part of the QGIS Open Day about open education for QGIS. I can share the link if I can quickly find it. But there are different examples where to find resources, and the best place to go for you is gisopencourseware.org, which is a site maintained by IHE Delft, and I'm the moderator, where we share courses on open source GIS for free, but also without support and without certificate, but just for yourself to learn more about it. And the course QGIS for Hydrological Applications, the translations of that are freely available. We have it now in French. So if you're from a French country, you can follow that whole course. French-speaking country, you can follow that whole course for free. We have it, I think, also in Portuguese now. Yes, a translator from Brazil. They're working on it in Chinese. Italian is being worked on, and Arabic. So there will be translations available soon. So it should be not too difficult to get started with QGIS. If you need the English course for QGIS for online, QGIS for Hydrological Applications, then that's a paid course offered by IHE, or you get the book QGIS for Hydrological Applications, this one, which is $35 for the ebook.
Thank you very much for that.
Okay, colleagues, it just was out for a minute due to a short cut in internet. I do see there's a few questions, Hans, that are looking about applications. So I have Ahmed writing about, I wonder if the knowledge gained by this course will be used for developing geospatial flood forecasting system as I'm researching development model. A similar question on applications is about, I'm more interested in more general applications. For example, computer sciences, can I also use that for this kind of applications? And also another person, Burns, does the course need to have a practical project? I work in a plantation in northern Mindanao, Philippines, on soil conservation, and managing hydrology is key. I think they're focusing a bit more on the applicability of the course tools that you will be sharing.
Yeah, this course will provide you a fundament. So you have to really see it as a sturdy, strong fundament that will help you to build on to go into more advanced applications that are also from different fields. These kind of courses, of course, need to choose certain themes, and it's also how we frame it. But you will see that the things that you learn are also very useful, especially the first few modules that you will get. And then maybe the PC raster and PyQGIS will be a bit more specific to certain applications, but still it will develop your ideas of what you can do with Python in other applications.
All right, thank you. There's also quite a lot of questions on the type of, software, specifically on QGIS, which version. I think that will be clear when people take the course itself, but also maybe some reference to R. Some people say, oh, we also have R. How do you relate this course to an R course? And actually R is even older. So maybe just to have a bit of reflection on that.
I want to comment to that one.
Go ahead.
I don't think it's older because it's around the same time that it started. It's not 2009 because I have been working with Python already in 2003. So it's much older, and they're very equivalent, and I've learned both. So I think if you get the whole concept and the logics of high-level programming languages, then it doesn't matter where you start, but you can apply it to other languages too. So if you have learned R, then you probably have it much easier to follow the first part of Python and vice versa. And I don't make choices in that. It just depends on your background, what you feel comfortable with. They're both open source, and I use them both in my work at Utrecht University with Etzer Pebesma, for example, who's one of the developers, also Professor Pebesma, in the spatial functionality and the geostatistical functionality of R. So I don't take sides there.
All right, I think that's fine. I don't see any, there's a few questions more on technical things, but I think also when we look into the course itself, that would be addressed. Maybe a very specific question, the script you're developing, can it also be used for dams? I think it would, but maybe you can give some reflection on that.
Yeah, for dams, but that's an engineering application. I'm more in the geography domain. That would be about planning dams. We have some master students who have been working on that also in QGIS to develop tools for that, and you can do that also in Python. Yeah, we don't really address that. We need to make choices, but the things that you learn, like the catchment delineation process, are really necessary if you also want to plan dams, for example.
Okay, thank you very much. I don't see any hands up, so I think we exhausted a bit the questions, and I think we're also quite on time for this question and answer session. If there's anything urgent in terms of questions, please keep asking. We'll respond. Some simpler question like, for example, will I be fine using a Mac? I think you already answered that, that it's indeed
Should
also
be
compatible. Right?
The thing about Mac, maybe I can comment on that briefly. Because I don't have a Mac and I never tried using my courses on a Mac. So the DOS commands that you will learn in the fourth module are not applicable to Mac, because as far as I understand, the Mac interface based on Unix, and you need to use the bash commands. But we use an emulator, so you can still use the commands of the course, but then in the emulator, but not on your own computer. So things will work differently, and I might not be able to offer support. So you're taking a little risk there, but it should work, but you need a good understanding of how a Mac works, and I don't have that.
Okay, that's fine. And of course, if you have any issues, you can always write to us using the Open Learning email address that also will be accessible through the course. And I think it's a good moment, because many of the questions are now related to the course itself, to maybe go into that, and I would maybe ask my colleagues to switch to the next slides so that we can basically have a look at that. All right. So just in a very few slides, I would like to guide you to the online platform. I will ask my colleagues also to share the link. So there's two links on this page. On one hand, you have direct link to the course, which is the upper one. But if you want to register and you haven't done so, easier ways to go to the openlearning.unesco.org address. You can register, and then you can enroll in any of the courses, including the Programming for Geospatial Hydrological Applications 1, which should already be live for about 15 minutes. So you can actually, just after this workshop, straight go to the course, and you should be able to access the materials. And those materials, you can see the next slide, how they look. So if everything goes well, you should be able to see on your left-hand side, there is a course outline. And that basically allows you to go through all the modules. You have 5 modules here that were explained already by Hans. And basically, after that, you also have a final assignment, which we're finalizing. And then you have a course evaluation and certificate element, which I will come back to, how you obtain a certificate of completion. Now, also, we have a discussion part of this course. And we would like to invite you to, if you have any questions specifically related to any module, we have included, please, next slide, a discussion element after each module. So you can always ask questions to the course developer as well as your co-learners. We also invite the co-learners to answer questions that you know the answer of, so that we also share the, let's say, the burden of looking after any issues or questions that may arise. As you have indicated, Hans, as well, it's a self-paced course, which means that there is no immediate attention to the course. We, of course, will check the discussion forum over time and see if any issues need to be solved, so we will do so. But it's not that we will be continuously checking the discussion forum. There's also a wiki forum, which in this case I think is quite relevant. We would like to build together with you kind of a repository of code that could be relevant for applications. So in this sense, we put a first, let's say, brick in the wall by providing kind of a starting point for such a wiki, where you can extract some of the lessons learned from the courses and add them to the wiki, which is visible to all. But also, of course, if you have your own elements to add that can be relevant, it can also be implemented there. This will be available after the course ends. It will be available to you indefinitely. So in this case, it is no loss of keeping it actual and accessible. So that's the wiki, and you're of course invited to contribute to it in a collaborative spirit. And the last one is also quite important. That's the progress page. So while you're doing your course, you also will bump into some of the exercises that Hans has prepared for you. You want to make sure that you understand some of the elements that were introduced, but also that you interact with the course. So in this sense, this is kind of for us a way to evaluate your progress in terms of integration and activity within the course. So we'll be able to check how are things going for all the learners. And at the moment, we have over 850 participants in the course. And also, after you achieved a grade of 80% of exercises, you'll be able to auto-generate your certificate of completion. And that option will become available exactly on this progress page. So once you go beyond the 80% mark, you'll be able to find a link to upload or get your certificate of completion for this course as well. And I think in brief, that's a bit what I wanted to share. I see a few people having still, or at least one person having his or her hand up. So I think it's Justin. If you want to talk or have a question on this specific item, you're good to go. You can unmute yourself and ask a question directly. Justin, if you want to ask a question, now is a good time. Maybe it was by accident. So in that case, I think we can continue. So maybe, I'm not sure if my colleagues already did, but I would suggest to copy the link to all attendees. So maybe if one of my colleagues can grab the link for the course and add it in the chat, that would be useful for everybody to access it directly from there. So maybe we'll wait for somebody to do that. And then I think if we can go to the last slide, where again, you can find that information. I think we're looking, yeah, maybe the last slide. Here again, this is the link. Of course, the second link is a bit easier to type, but we'll make sure you have the two links in the chat. As you can see now, I see my colleagues already have a good collaborative spirit because I see several people already pasting it in the chat. So thanks for that. And I hope we can keep up that collaborative spirit during the course. Maybe also to mention that for us, it's also kind of a base course. I think that for us, we see this as a critical skill on which we would like to build additional capacities. And of course, we will see with the staff of IHE, and specifically with Hans and the team, to see what additional courses we will bring that could connect to this course. And at the same time, we may put this course as a precondition for further learning, either physical courses when the COVID condition allows, or further online courses. So it means that having this course done will be kind of a precursor for further capacity building. And of course, we can gauge from you additional interest that you may have, and you can put that in the in the evaluation form at the end of the course. If you have any suggestions for further learning, we're happy to hear it from you. So I think I will just stop here with this short introduction on the online learning platform. We're happy to explore further. And of course, if you have any questions, you can also write us an email on openlearning@unesco.org if you have any technical problems that arise from the platform itself. So I think with that, I would like to go to the last session. I see one more hand up. Let me just check. Ayuba, you would like to ask a question? If so, you're good to go. And I have one more question after that. So Ayuba, you should be able to unmute yourself and speak. If that's your intention, you can do so now. If not, I will go to the next one and you can still come in later. So that would be Matunyawa. Matunyawa. I also see that person having challenges. I have a few more hands up, so I'll just have to continue, I also, Solomon, I will unmute, you can unmute yourself if you have any questions. Okay. Solomon, Matunyawa, Ayuba, or Justin, if you want to take the floor, the time will be now. If not, then we will continue with the final remarks. Okay, I see Solomon, you lowered your hand. Okay, so I think for now we don't have any further questions, so we'll finalize this webinar and initiate the course. I would like to give the floor to the head of the section Hydrological Systems and Water Scarcity in UNESCO headquarters under the Intergovernmental Hydrological Program, Dr. Anil Mishra. So Anil, please, floor is yours for some final comments.
Thank you, Koen. Can you hear me?
Yes, we can. Please go ahead.
Yeah. Well, thank you very much. First of all, happy birthday, Hans. What a celebration. At the height of this webinar, I saw more than 317, if I'm not mistaken, participants celebrating your birthday with the launching of online course Geospatial Hydrological Application, and within the framework of ClimWater, which is enhancing climate services for improved water source management. Fantastic course, though I quote what you say, if you don't learn, someone will learn, definitely. And this is something that, I became nostalgic when you were presenting the course. In my lifetime, I was using Fortran and VBasic and other languages. Python was not there at that time. So it's a fantastic technology, and to learn, particularly to generate data for climate services. So I would encourage all the participants. I just want to reflect a couple of things within the framework of this ClimWater project. We enhance climate services and build a data knowledge base. So this is along the line of ISP's intergovernmental program, which is, by the way, moving into the 9th phase, Science for a Water Secure World in a Changing Environment. And within the framework of 9th phase ISP, with members, we will be implementing activities to enhance scientific research and innovation, water education in 4th industrial revolution, bring data and knowledge gap. So these are the areas that will prepare with this skill for the member states. So I would encourage again participants to sign up for this course. AD reflected that we are off the track, SDG of meet SDG goals off the track, and there is a global accelerator framework and particular capacity development, innovation, improve data and information, and UNESCO volunteered itself to contribute to capacity development. And in that sense, as we've been talking to you at IHE, with the member state, with the university in Brussels, to come up with new ideas. And last year also, UNESCO came up with the open science recommendation. So within this framework and the implementation that is done from here, Harare office, is fantastic. We can really replicate these ideas. And so, and printed in open water network, perhaps we can have a course on this hydrological application in e-masters program that's presented, in which UNESCO is collaborating, and we will continue to collaborate. So once again, I'm sure this was many months of preparation undertaken by Harare office in coordination with IHE, with all the other colleagues involved. So I would like to thank everybody, and also IHE for collaborating with UNESCO. And there are much more to be done, and we will continue to work with you. And best wishes to all the participants, so that you can get your 80% mark and get the certificate. And as Kun said, perhaps this could serve as a prerequisite for the next level of course that ISP will continue to work. Thank you very much, and wish you all the best.
Thank you very much, Anil. And I think with those final and closing remarks, I think we can finalize this quite successful webinar. I think we were reaching up to 300 participants at the height of the meeting. So I think this was a very good attended webinar, and I hope also that you enjoyed the course as much as I did myself. And as I said, that it will be a starting point for further work on open science and open applications for water resources management. Thank you all for your attention, and we look forward to working with you in the next few months during the course execution. Thank you all, and see you soon.
Thank you.
Thank you.
Recording stopped.